The acronym or abbreviation IC stands for Integrated Circuit. In this class, we shall discuss passive component, active component of a circuit, what we mean by discrete circuit, we shall discuss the journey towards integrated circuit, abbreviated as IC. We have to know what we mean by wafer or substrate. The term chip will also be described, and then IC or integrated circuit will be defined. We shall discuss also the advantages of integrated circuits, and we shall also discuss about classification or the types of IC, though the details of each classification will be taken up in the next video. Let us start with passive component of a circuit. It will be easy if we start with examples of passive components. For instance, R for resistance, C for capacitance, L for inductor or inductance, which are all passive components of a circuit. These components function when they are part of a circuit which is energized by any supply voltage, say 0.3 volt or say 0.7 volt or 5 volt, etc. That is, they do not need a specific voltage for their operation. Any voltage or any setting is okay for them. Let us now describe what we mean by active component of a circuit. It will be easy again if we first give example of active components. The examples are diode, transistor. These components require specific external source voltage to function. As for example, a silicon diode will not conduct either with forward bias or with reverse bias until the level of voltage reaches while for a germanium diode it is 0.3 volt. Also, they produce and inject power or energy into a circuit. For instance, generator, battery, current and voltage source, we now describe what we mean by discrete circuit. We can build a meaningful circuit by connecting the passive and active components with connecting wires through wire binding or soldering. Let us show a few discrete circuits. It is clear from the diagram of the discrete circuit that the components passive and active occur as discrete, that is separate components. Their terminals are connected through wires or through soldering. We now describe the journey towards integrated circuit. Let us be reminded of a famous machine of 1946, which is called ENIAC. This acronym or abbreviation stands for Electronic Numerical Integrator and Computer. It included 17,000 vacuum tubes for its operation. We also recollect the Boeing B-29 of 1944. This Boeing, when pressed into service, had to carry 1000 vacuum tubes, 10,000 passive components, of resistor, capacitor, inductor, etc. At that time, electronic circuit design was approaching a stage of saturation. Traditional electronics reached a deadlock, so to say. Since every additional component reduced reliability, lengthened startup time, troubleshooting time. Also, errors and failures of device led to losses that exceeded expected benefits. In 1947, transistor was discovered by American physicists Bardeen and Brattain while working under the famous Shockley at Bell Lab. This reduced size of components and power consumption. Let us consider the schematic diagram of two complex devices. One is the 555 timer that involves 25 transistors, 2 diodes, 15 resistors, or say 741 op amp. That includes 22 transistors, 12 resistors, 1 capacitor. Having drawn a schematic diagram or having proposed a structure which is definitely very complicated, it looks awesome. To be precise, how would we form or fabricate it? One way is to use a breadboard. And fabricate the circuit on the breadboard. But look at the complexity of the circuit. Most importantly, the number of components used. The passive component and active component is very large. So the breadboard would completely be used up. Clearly, the circuit would take up or occupy a large space, and this is a disturbing aspect. Also, it then becomes virtually non-portable. There is another problem associated with dense packing of components into small space. In case of a malfunction of a part or component, it is difficult and time consuming to identify the error and repair it. So the need of the hour is how to integrate that is add or combine various components in a very short space. In other words, to achieve miniaturization. In a cost-effective and efficient manner. This needed a new technology that was invented by Kilby and Noyce in 1959. And this was the birth of information age. Now the question is, what did they invent? They formed or fabricated the entire circuit that is components plus their interconnections. Say the schematic circuit in its entirety. On a material which is called substrate or wafer. Now what was the material? The material can be silicon or glass or ceramic or plastic and so on. And what is a substrate or wafer? Evidently, substrate or wafer refers to the base material on which fabrication is done. If it is a thin slice of silicon semiconductor, we say that we have a silicon wafer or silicon substrate. Let us now define what we mean by chip. The circuit on the semiconductor material that is on the wafer or substrate is called chip. The chip is connected to external terminals or pins with which we can connect the chip to a larger circuit to build a device. The chip attached with pin is now protectively packaged. That is, the block of semiconductor material, the chip with pin, is encapsulated in a supporting case to prevent physical damage and corrosion, and to allow easy handling. What we have got now is an IC or integrated circuit. Let us make a gist and then we shall define IC formally. We had a schematic circuit representing a device that is passive plus active component plus their connections This is fabricated on a wafer or substrate, say silicon substrate, So we get the chip now attach pins to the chip. Now chip is attached with pins and the chip with pin is packaged. And finally, we end up with the integrated circuit. We now come to the definition of integrated circuit. IC or integrated circuit refers to a circuit fabricated on a substrate or wafer, say silicon, to form a chip. To which external pins are attached. And then protectively packaged. IC obviously has become the backbone of electronic circuits. Say computer, mobile, TV, fridge, and several other gadgets. Now let us ask the question, which components are fabricated? The fabricated parts are passive components like resistor, capacitor, as well as active components like diode, transistor. It might be bipolar junction transistor, field effect transistor, or metal oxide field effect transistor, MOSFET. Let us make a mention of the components that are not fabricated. They are the coil or inductor, transformer. Both of which are passive components. Why are they not fabricated in an IC? This is because their size is large. So cost of integration will evidently be large. Also, making them small in size is very expensive compared to the other components like resistor, capacitor. So, designer avoids their use in integrated circuit. They are therefore used externally in circuit. It is now time to discuss the various advantages of integrated circuit. First, the miniaturization. Or the small size that we have attained through construction of integrated circuit. Large number of passive and active elements or components get packed up in a small space along with their interconnections, and what results is a high packing density. So the device that the packed circuit stands for will occupy a very small space. We thus have a miniaturized device, and hence we have thin laptops, thin mobiles. There may be a billion of transistors. Packed in an area of size that of a human fingernail. The second point that strikes us is that integrated circuits are cost effective. The technology used in fabrication of large number of passive and active elements or components in a small space over a silicon wafer or substrate is called IC technology. Designing and fabrication of integrated circuit is a costly thing. So to make it cost effective, high production volume is required. Hence, batch processing or batch manufacture is done. That is, large number of ICs are produced at one go. And it so happens that the individual components are costlier than an IC chip. The third advantage that comes to our mind is that of matched or identical ICs. Or easy replacement of ICs. If one IC is damaged in a circuit or a device, we can immediately replace it by another IC which is readily available. The fourth advantage is increase of reliability. In manual fabrication of an electrical circuit, we solder and join components. Thereby, there is possibility of loose contact, and so reliability diminishes. But in integrated circuit, there is no soldering, that is, soldered joints are eliminated, and naturally reliability enhances, that is, increases. Next, increased operating speed. With IC as a part of a circuit, a device operates fast, that is, it is endowed with high switching speed. It can start, reset, restart fast and without any significant delay. Next, what comes to our mind is improved varied functional performance. An IC can function reliably as an amplifier, an oscillator, a timer, counter. It can function as computer memory or microprocessor. Another very attractive feature is its low power consumption. This is because it has small size and the components are very near to each other. That is due to the proximity of the components. Also, it is very easy to work with integrated circuits. We now focus attention on the classification of IC. ICs can be categorized or classified in various ways. We shall discuss details in the next video. In this video, we simply mention the basis of classification. One way to classify ICs is on the basis of chip size. That is on the basis of number of components integrated into the chip. Number of logic gates incorporated into the chip. Accordingly, we shall come across terms like SSI, which is small scale integration, MSI, which is medium scale integration, LSI, which is large scale integration, VLSI, which is very large scale integration, and also ULSI, which is ultra large scale integration. Another way of classifying ICs is on the basis of the technology that is used. In other words, depending upon fabrication technology, how fabrication has been done, we shall come across then terms like monolithic IC, hybrid or multi-chip IC, thick and thin film IC, A yet another way of looking at IC is to classify them on the basis of the signal processed. Now, signal is of two types. One is analog signal, the other is digital signal. Accordingly, we shall come across terms like analog IC, digital IC, mixed signal IC. We can classify ICs also on the basis of input-output relation. Whether it is linear or not. And then we will come across terms like linear IC, digital IC. The fifth way to classify ICs is to see how ICs are packaged, that is, on the basis of packaging. We shall discuss how chip is enclosed in a case. And we will come across terms like metal can pack, or TO pack, DIP pack, which stands for dual inline pack, or the flat pack.